Have you ever felt like your favorite app is, I don't know, reading your mind? Well, today we're going to pull back the curtain on the science that makes that magic happen. We're diving into how the internet learns what you love without you ever having to say a single word.
All right, let's just jump right in because you know exactly what I'm talking about, right? You finish one article and bam, another one that's just perfect pops up. Or you buy something and suddenly you're seeing all these other things you didn't even know you needed. This isn't some kind of psychic power. It's the science of implicit feedback.
So here's the first piece of the puzzle. It's this idea called implicit feedback. And really, you can just think of it like the digital breadcrumbs we all leave behind online. Every click, every video you finish, every single item you add to a cart, it's all a signal. Even though you aren't literally saying, hey, I like this, your actions, they're speaking volumes.
Okay, so we're leaving all these clues, right? But here's the thing. Turning those clues into something useful is a huge puzzle for data scientists. It's definitely not as simple as just, counting clicks.
And this gets us to a really core trade-off. See, you've got two kinds of feedback. On one side, there's explicit feedback, like a 5-star rating. Super clear, right? But how often do you actually do that? It's pretty rare. Then, on the other side, you've got implicit feedback. And that stuff is everywhere. But the big catch? It's messy. It's noisy and indirect. And that noise creates 4, let's call them big challenges that these algorithms have to wrestle with. First up, there's no negative feedback. So you didn't read an article. Why? Did you hate it? Or did you just not even see it? This system has no idea. Second, just plain old noise. Did you click that link by accident? Or maybe you bought that blender, but it was a gift for your cousin, not for you. Third, you've got this tricky difference between preference and confidence. You might read a daily news summary every single day. That shows high confidence you find it useful. But you might have preferred that one amazing article you only read once. And finally, how in the world do you even know if the recommender is doing a good job if there are no ratings to check against? These are the puzzle pieces engineers are constantly trying to put together. So you might be asking, how did engineers even begin to crack this code? Well, it all started with a couple of foundational playbooks, 2 main ways of thinking about the problem. Yeah, you can think of these 2 main approaches like 2 different kinds of detectives. The first one, collaborative filtering, it looks at the behavior of people. The other one, content-based filtering, it focuses on the characteristics of the things themselves. Let's talk about collaborative filtering first. The core idea here is so intuitive, it's basically you are who you read with, right? If you and I have both liked the same 10 articles, the system makes a pretty good bet that you'll also like the 11th article that I loved but that you haven't seen yet. It's all about finding your taste twins out there. Now, on the complete flip side, you've got content-based filtering. And this one, it totally ignores other people. Instead, it looks deep into the content of what you like. So if you read an article about machine learning, it'll break it down by keywords and topics, and then go find other articles that are just like it. The whole idea is, if you liked this, you'll probably like that.
Okay, that sounds pretty good, right? But there's a huge catch. What happens when a brand new article gets published, like right this second? Nobody has read it yet, so collaborative filtering, it's completely blind. This right here is what engineers call the item cold start problem. And trust me, it's a massive headache for recommenders. But this is exactly where content-based filtering gets to be the hero. It can analyze the text of that new article instantly and start recommending it to the right people. It solves that cold start problem right out of the gate.
So those 2 foundational models were the bedrock for years. But today's systems, they've evolved way, way beyond that. We're in the deep learning revolution now. A really good way to picture this is like an evolutionary ladder. At the very bottom, you have those foundational models we just talked about, just looking at who likes what. Simple stuff. Take a step up, and you get to sequential models. Now, these are a lot smarter. They don't just see what you clicked, they see the order you clicked in, figuring that what you read 5 minutes ago is a much better clue than what you read last month. And then at the very top of the ladder, you've got graph models. These things see the entire ecosystem as this giant social network of users and articles, learning from all the connections between them. So these graph neural networks, or GNNs for short, are just incredibly powerful. Try to picture it like this. Every user and every single article is a little dot or a node on a gigantic network. When you read an article, a line gets drawn between your dot and the article's dot.
GNNs learn by watching how information flows and bounces around this massive web, and they can pick up on these super subtle patterns that older models would just completely miss. But get this, here's where it gets really interesting. A team of researchers developing a model called LightGCN, they found something totally counterintuitive. They discovered that for this specific job for recommendations, making the GNN simpler actually made it better. They literally stripped out some of the complex parts that are standard in other areas of AI, and boom, performance went up. It's just a great reminder that sometimes less is absolutely more.
Okay, so we've got all these amazing advanced tools. The obvious question is, which one's the best? Well, it turns out the answer is less about raw power and more about smart strategy.
And this table here tells the story perfectly. There is no free lunch. You know, your classic simple models like item CF, they're easy to build, but their performance is just fair. Then you move up to these advanced AI models like BERT4REC, which understand the sequence of your actions. The results are excellent, but wow, are they complex. And they still don't solve that cold start problem. To really get the best of all worlds, top-tier performance and a fix for new items, you need a hybrid model. And as you can probably guess, that's the most complex of them all.
So what's the big takeaway here? The crucial point is that choosing a recommender model isn't about some epic quest to find the one best algorithm. It's about finding the right one for the job. It's a strategic choice, a balancing act between performance, complexity, cost, and the specific problems you're trying to solve.
And that really leaves us with one final thought to chew on. We've gotten incredibly good at predicting what you might like, what you might click on next. But the real next frontier, the next big challenge, it's not just about prediction. It's about discovery. It's about helping you find something you will absolutely love, something you didn't even know you were looking for. And that's a future that's really exciting to think about.